Hello everybody, this is Philip Jonas at Kalamazoo Valley Community College presenting OpenStax Principles of Economics, and today we're covering section 5.2, Extreme and Unitary Elasticities. In this module, you will learn how to differentiate between infinite and zero elasticity, and how to analyze graphs to classify as unitary, infinite, or zero elasticity. In our last module, we learned the basic calculation for elasticity, comparing a percentage change in one variable to a percentage change in another, or in our first two cases, the percentage change in quantity caused by the percentage change in price of that same variable. Please remember, we categorize this into three major categories all around the number 1. So the number 1 here, very special. That's a unitary elasticity, which ends up having a very special property we'll get to in a few minutes. But if our elasticity comes in greater than the number 1, that will be elastic, and less than 1, inelastic. So let's start out by looking at some extreme examples and how they relate to this scale. So if you want to think of elasticity as like a range, we have our unitary elasticity right in the middle. And as we talk about less and less elastic, so as we go below the number 1, we're inelastic, but that can go all the way down to 0, perfectly inelastic. Then on the other hand, on the elastic side, so greater than 1 now, we can go bigger and bigger, very large elasticities, until we end up approaching infinity itself for a perfectly elastic curve. So what does that look like, and what does it mean? Let's start out by looking at a demand curve. So this demand curve, obviously, very unusual looking, very different from what we've discussed so far. If we want to look at this from the perspective of elasticity, notice that regardless what's happening to price, we could just have any percentage change in price going on over here, the quantity demanded doesn't move at all. That's what elasticity here is measuring when it comes to the price elasticity of demand. How responsive is quantity demanded? Answer, 0. It isn't. And of course, if we put a 0 into the numerator of any fraction, that fraction ends up being 0 itself, which is why a perfectly inelastic curve may also be referred to as zero elasticity. So what's going on here? Well, we've got a product where people just don't change how much they buy, no matter the price. Let's look at the opposite situation. Here's a demand curve, once again, a little bit strange looking, flat, completely flat. So if we want to look at this in terms of our elasticity calculation, that actually ends up being a little bit tricky, because percentage change quantity demanded over percentage change in price. Well, what's our percentage change in price along a horizontal line? Nada. We've got a 0 down there in our denominator. So what's a percentage change in quantity divided by 0? Trick question. You can't do that. That's an undefined number, right? Nope, that's just out of the question. However, just to have you a little bit aware of how economists might talk about this perfectly elastic demand curve, if you end up applying super nerdy advanced math and say, hey, as the percentage change in price here approaches 0 from a bigger number, you could say that this elasticity is approaching infinity. Don't worry about it. The point is, if somebody says infinitely elastic demand, that is why. So these are our extremes, the perfectly inelastic and the perfectly elastic demand curve. But of course, they all revolve around this point in the middle, unitary elasticity. So what's going on there? Well, here you're looking at a unitary elastic demand curve. I'll show you the calculation. I'll show you why we care about that number, about the special property it has. And you're probably noticing the point D here isn't quite on the curve. Well, I don't know how to use Adobe Illustrator all that well, so I'm going to need you to get all the way off my back about that. And let's go back to the math where we calculate out the percentage changes here. Again, spoiler alert, the resulting elasticities end up being 1. So that, of course, means that the percentage change in one variable is equal to the percentage change in another variable. So let's go ahead and travel down this demand curve. So starting at point A, traveling down on the price axis, we have a $3 change in price divided by a $7.50 midpoint. That's a 40% change. And at the same time, advancing from a 50 quantity to a 75 divided by the middle, also a 40% increase. 40 over 40, of course, absolute value rules apply. This ends up being exactly the number 1. Let's do it again. Going from $6 to $4.50 over the middle of $5.25. That's about a 28.6% change, while at the same time going from 75 to 100, we have the same percentage change. Once again, the number 1, even if the percentages, of course, are not necessarily the same, right? We're looking for 2 percentages that are equal to one another. That makes the fraction equal to the number 1. And even for our last 2 points here, back to the 40%, going from 450 to 3, going from 100 to 150, 40% changes again. So notice when it comes to a unitary elastic demand curve, don't let the intuition of slope mislead you. That's not a straight line. In fact, if you want to use a fancy term, it's a convex line. It's going to be bowed towards the origin. And there's a good reason for that. Because our preferred measure of the shape of a demand curve, this elasticity measure right here, has one property that we find just super nifty and useful. If 2 points result in the same amount of money spent on the product, we call that total revenue. If 2 points have the same total revenue, the elasticity between those points is equal to the number 1. So let's go ahead, travel down this demand curve and see that in action. So point A, we've got 50 units being sold at $9. So when we talk about total revenue, that's price times quantity. How much money are consumers spending on the product? We're not yet talking about profit. Profit is revenue minus cost. We'll get to that down the line. Just the revenue of this particular product, 50 units at $9 each. That means consumers are spending $450. Advance to point B. More units are being sold at 75, but the price is lower, only $6. However, since the elasticity is equal to the number 1, we already know how this is going to work out. Once again, $450 on the nose. Point C, very easy to see, 100 units, $4.50 each, $450. And of course, finally, point D, giving us the same result. And that's our first application of combining the concept of price elasticity of demand with revenue. Of course, those elasticities won't always be equal to the number 1, so we will see in the next module what happens with elastic and inelastic demand. For now though, let's have a look at our friend the supply curve. So here's a supply curve that ends up being unitary elastic, and this one is a straight line. In fact, spoiler, any straight line supply curve that goes through the origin ends up having an elasticity equal to the number 1. So this one does work a little bit more in line with the concept of slope, but I hesitate to even say that because it isn't the same as the concept of slope. So let's go ahead and use this as a great opportunity to practice our elasticity calculations a little bit more. Starting at the bottom of the curve, point D. Going from $4.50 up to $6, that's a $1.50 change on a 525 midpoint, is a 28.6% increase. We're looking for the same increase over on the quantity side to give us a unitary elasticity. So here we're looking at 30 points over a 105 middle. Again, 28.6%. Let's bump it up again from E to F. We're taking the price up another $1.50. So does that mean we're going to get the same percentage increase? Of course not, because we have a different middle where we are putting it in relation to. So the percentage change is smaller this time, 22.2. Compare that to our quantity supplied, decreasing 30 points again, but this time over a 135 middle. So it too works out to 22.2%. One last time, another $1.50 increase in price, this time over an 825 middle, so we're now getting our smallest percentage change on this graph of 18.2. And of course, our quantity supplied works out the same way in terms of percentage increases, 30-point increase over a 165 middle, another 18.2. Again, totally unexpected result. Because anytime you've got a straight line traveling through the origin, that's going to have an elasticity equal to 1. So in this module, you learn to differentiate between infinite and zero elasticity. And also, we looked at some graphs so that you can classify them by looking at them. Are they unitary, infinite, or zero elastic? I will see you next time.